for me.
All right. We'll give it one more minute here and we will get started. So I just asked that everyone just make sure your mic's on mute, except for myself, Connor Glowacki, Dr. Neuzil, and Mr. Reeves. If everyone else could just keep your microphone on mute. So again, if you guys have any questions for Dr. Neuzil, if you can just write them in the chat right now. So there's a chat bar at the bottom there. If you have any questions for Dr. Neuzil, just indicate so, and then we'll call on you after we do our little introduction for Dr. Neuzil. So again, just indicate that you have a question, and then we'll make sure to call on you. Okay, so let's see. All right, Connor, if you want to get started.
All right. Well, hello, DeMatha Nation. Welcome to our 75th anniversary DM Speaker Series. My name is Connor Glowacki, staff member here at DeMatha, and I'm joined today by staff member and 2011 alum Ben Flary, and faculty member and chair of the science department, Mr. Rick Reeves, who is in his 31st year here at DeMatha, as they both will assist in our interview with Dr. Kathleen Newtzel, current director of the Center for Vaccine Development at the University of Maryland School of Medicine. We're very honored to have Dr. Newtzel join us today. She studied zoology at University of Maryland, was a medical student at Johns Hopkins University, and completed her residency at Vanderbilt University in 1987, where she specialized in internal medicine. A few years later, in 1991, Dr. Newtzel was made a fellow in infectious disease at Vanderbilt. Alongside her academic positions, Dr. Newtzel serves on the World Health Organization Strategic Advisory Group of Experts on Immunization, and previously on the advisory group of the Centers for Disease Control and Prevention. At the Center for Vaccine Development, Dr. Newtzel has developed and employed vaccines to protect against a range of diseases, including typhoid, fever, and malaria, and has also considered emerging pathogens, such as the Zika and Ebola viruses. In 2016, Dr. Newtzel was awarded by the Vanderbilt University School of Medicine Distinguished Alumni Award, as well as named among the top 100 women in Maryland in 2018. In 2019, she was elected to the National Academy of Medicine, and in 2020 was named Marylander of the Year by the Baltimore Sun. Currently, Dr. Newtzel acts as the director of the Center for Vaccine Development at Maryland School of Medicine, where she has been since 2015. And with all that, it is my pleasure to introduce our special guest today, Dr. Kathleen Newtzel. Doctor, thanks for joining us. And before we get started, how has the pandemic altered your life working at the University of Maryland School of Medicine, especially in this important work that has really gotten a lot of more mainstream notoriety, I feel like, in the past year?
Yeah, well, thank you for the introduction, and it is fun for me to see lots of familiar faces here. You know, I lived away out of Maryland for about 30 years and came back about 5 years ago. So it's been fun to be back in the state and back in the neighborhood and catching up with everybody again. Yeah, we've been at this now for about 14 months. You know, I remember getting a phone call in January about a viral sequence that had come from China, and that's when the work on the vaccine began. You know, there hasn't been a lot of teleworking here. We've pretty much been coming in most days. It's been quieter, but we've certainly been here most days, our laboratory workers, and then again being involved in a lot of the clinical trials. So I'm sitting alone in my office, but please know I've got shields and masks, and you know, we obviously have followed all the rules along the way, and feel very fortunate now to be rolling out vaccines and have at least most of our staff who have received the vaccine.
That's great to hear, obviously, especially with everything going on. Can you describe, and we went over a little bit in the intro, you know, how you got involved, what made you want to study vaccine developments, and, you know, going back to your, you know, days, just what ultimately made you want to choose this career path?
Yeah, so that's a great question. As many people on this call know, I don't come from a family of physicians or scientists. I do come from a family, though, where my parents certainly valued hard work and academics and pushing ourselves as far as we could go. So I suppose, at Regina High School, I really favored the biology and the chemistry and the science classes, and that continued at the University of Maryland. Truthfully, I didn't know a lot about medicine and all the options until I arrived at Johns Hopkins. Again, we're really fortunate in this state to have such prominent schools, and really opened my eyes there to just many of the best scientists and physicians in the world. And I would say it was during medical school that I really got turned on to this idea about preventing disease and not just treating disease, and learning about the influenza pandemic of 1918 and how much morbidity that caused, and just the medical miracles that vaccines are.
Thank you, Dr. Newtzel. So before I get to Mr. Reeves' question, I just wanted to ask, so obviously, like Connor mentioned earlier, grew up, went to St. Mark's Middle School, Regina High School. I believe, actually, my cousin went to Regina High School. I think she was in the 70s as well. Last name was Flary. I don't know if you know her, but so I just wanted to see, how anything you wanted to say, maybe in particular about the DeMatha community, or maybe any memories that you have from your high school days. Maybe you could talk a bit how you're tied to DeMatha.
Yeah, well, again, living away from Maryland for 30 years, I didn't run the risk of running back into my high school friends. So I will hope Tommy Ponton and Tom Carruthers and a few others don't share every story about me in high school. However, Meg Carruthers and I were good friends. We had a lot of fun. We certainly had a lot of interactions with the DeMatha community. I'm assuming Tom Ponton put this out, but my brother-in-law, Pat O'Connell, went to DeMatha. We were always going to football, basketball, DeMatha baseball games, and at Regina, our big rival was Seton, and I played on the basketball team. And because Regina had this tiny little gym, we usually played Seton at DeMatha. So those were fun memories as well, playing on your old court. I've now been to your new court, but your old court was still far superior, your old gym, to our tiny little Regina basketball court.
That's great. Thank you, Dr. Newtzel. Rick Reeves, if you want to go ahead.
Sure, Mr. Flary. So it's very nice to meet you, Dr. Newtzel. This is an area that I have a great deal of interest in because my own graduate research was in prokaryotic pathogenic microorganisms. And of course, I teach a couple of sections of advanced placement environmental science here. And we actually specifically spend about a quarter of our classroom time talking about public health and infectious diseases. So I've actually talked to some of my students and some faculty members. And so I have some questions that they have asked me to sort of bring up. So I'll ask some of their questions and maybe you can give us some insight on that. One of the questions that some of my students had is that they were very interested in how we develop vaccines. So could you sort of briefly explain the process? And also they were very interested in why it, in their perspective, takes so long to develop a vaccine, though we know that with COVID, this has been pretty rapid when it comes to vaccines. So maybe you could address those two questions for us.
Sure. So those are two really good questions, and you've probably been reading in the newspaper. We've never quite had a year where vaccines are on the front page of the paper. We're not used to that in this field. And there's been a lot written about how long vaccine development usually takes. And that is because it's a very careful, deliberate process. We start in the laboratory and we try to identify the best antigen. What is it about that virus or bacteria? How are we protected? What's the best way to make a vaccine? Then you have to put it into some format that can actually be given, right? So there's the whole chemistry part of it. Do we conjugate it to a protein? Is it in a liquid form? Is it in an injectable form? And all of that. And then there's a lot of testing in animals and in the laboratory before we ever get to humans. And then we start with human testing, which we start with the healthiest population, generally young and middle-aged adults. You know, we give low doses of a vaccine, we move to higher doses of vaccine, we monitor people very carefully. Then we start giving the vaccine to larger numbers of people, and people who aren't as healthy, people who may have chronic conditions, older people, children, pregnant women. And then we do the very large efficacy trials that you've probably read about in the paper of, you know, 30,000 people, 40,000 people that were in these clinical trials. So that's the typical way we do it. So the real question is, how were we able to do all of this in a year? And I'm asked that question a lot, and I really give three main answers. You know, one is the science, that our science has really progressed to the degree where we were able to not have to purify a virus and a piece of a virus, but we were actually able to use the genetic sequence of the virus to develop those first mRNA vaccines. And, you know, those mRNA vaccines have actually been studied for decades. So had they not been studied for decades, we wouldn't be where we are right now. And similarly, because we had SARS-1 that predominantly affected Asia, there was a big outbreak in Canada. Scientists at the NIH had studied coronaviruses, understood the immunity, understood you know, what protein, that S protein would work, and had already made vaccines for SARS-1 and for MERS. So we were at a very high starting point. Had this outbreak been caused by an obscure virus or a rare virus or something that people hadn't studied for decades, we probably couldn't have done it in 11 months. The second huge answer are resources. The amount of money that went into this is unprecedented. And this effort was paid for by me and you and the taxes of everybody on this call. So the US government put in billions of dollars to develop these vaccines. And what that meant is that we could take risks and we could do everything at once. You know, we could test in multiple animal models at once. We could start making the vaccine before we knew if it was going to work in the mice. We could start making the human vaccine. We could have a study of 30,000 people instead of having a study of 3,000 people that would take longer to get where we needed to go. So those resources made a huge, huge difference in accelerating the timeline. And then I think the third reason is partnership. You know, the US government brought all the manufacturers together. They brought the FDA together. I should have mentioned that when you asked about vaccine development. It's not just the science, it's the regulatory piece. You know, it has to be reviewed by the FDA. It has to pass all of these conditions. So the FDA was at the table and NIH was at the table and the manufacturers were at the table. So everybody was working together toward this goal, sharing experiences, so you didn't have, you know, one mistake made by one company and then the other company repeated the same mistake. And I think a good example of this was in the paper 2 days ago, where Merck, you know, a major vaccine manufacturer, is going to help Johnson & Johnson make their vaccine. We just don't. If vaccine development is business driven and profit driven, you're not going to see this kind of collaboration. But because the government de-risked the investment and put the money in, people all work together toward the goal.
Thanks, Dr. Newtzel.
Great.
We got a couple questions for you. First, we have from Tom Carruthers joining us from the West Coast. Tom, if you want to unmute your mic and ask your question.
Hi, Kathy. I wanted to know if once you've tested positive for COVID and recovered, are you still able to spread that COVID disease to others? And can you, again, catch COVID if you've already had it and processed through the system and recovered?
Yeah, so a really good question, important public health question, and important question in terms of, do we keep wearing masks? Do we get, so from what we know, and we're learning a lot as we go, people who get COVID are unlikely to get COVID again, at least for 6 or 8 months. Now, we haven't studied the virus that long, right? So whether it'll reinfect you again in a year or 2 years, the way influenza does, we don't quite know. But of course, that can be variable because your immune response is better if you get a more severe case. So you're always going to have the exception. You may have the person with the mild case who can get it again. But for the most part, you're protected for at least a period of time. It's looking like the vaccines on average may be actually better than getting infection at protecting. But again, we have to follow over time. So the big question is really the one that you're asking, that even if having COVID before or getting the vaccine for COVID keeps us from getting sick again, can we still get the virus and shed the virus and infect others? And so the answer to that is yes. However, it appears that it is less, you shed less virus for a shorter period of time than somebody who hadn't been vaccinated or hadn't received the vaccine. And we're also trying to directly quantitate that. So that's a very active area of research. So that's why we're saying for now, even if you had COVID and even if you had the vaccine and you're less of a risk, you could still be a risk. You should still wear a mask. Once everybody's vaccinated, then it doesn't matter so much, right? Because even if I'm still shedding a little bit, you're protected. So I think we can perhaps start with fewer restrictions when we get more and more people vaccinated. But for now, we're probably less of a risk to others. But if you've been infected or vaccinated, you can still pass it on.
Thank you, Dr. Newtzel, and thank you, Tom, for a great question. We'll try to get to everyone's questions here. We have a question from Shane Dedman. Shane, if you want to unmute your mic and ask Dr. Newtzel a question.
Hey, Dr. Newtzel, this is Shane Dedman here. Not to get into a political discussion, but what are your thoughts on the states starting to reopen in full force with no masks, no social distancing like Texas just did?
I would say most scientists and public health officials would say that what Texas just did is a mistake. For the reasons I've just explained, it's too soon. They still have a very large percentage of their population that is unvaccinated. I think there are ways to gradually, increase numbers in businesses or whatever they are trying to accomplish. But I disagree, and I think it's reckless actually for them to have made that decision.
Awesome, thank you.
Thank you, Dr. Newtzel. We have a question now from James D'Amico. So James, if you want to unmute your mic.
Yes, doctor. I had both of my Mrna vaccines about a month ago. First one was New Year's Eve, and the second one was the 28th of January. Just how effective are they, that particular vaccine?
Yeah, these mRNA vaccines, Pfizer, Moderna, the Johnson & Johnson vaccine is very good too. These are remarkably effective vaccines. I have to say, when the FDA first put out the guidance and when we were first designing these trials, we set a bar of about 50%. And these vaccines are over 90% efficacious. So, more than 9 out of every 10 people who are exposed are protected and will never get the disease. And those who do have a lower severity of disease. So really remarkably effective. The two big questions are, how long will that last? And we don't know because, we only gave the first vaccines last May. So we know that this immunity appears to last for about 8 months, and we'll keep following those people. And then the second big question is just how well can you still transmit virus? And that's the unanswered question. But as individuals, we are very highly protected from these vaccines.
That's great news. Thank you, Doc.
Thank you, James. So next question we have here for Dr. Newtzel, Nick Davis. Nick, if you want to unmute your mic and ask Dr. Newtzel your question.
Hi, Dr. Newtzel. You've kind of touched on this already as far as the longevity of the vaccine itself. So my question would be, if for whatever reason, after 8 months or however long it may be, there's like a mutation in the strand of the RNA of the virus, how, like from a developmental standpoint, how big of an issue would that be with finding a new protein to inject, or as far as vaccine development goes?
Yeah, so we were hoping we wouldn't get to this point that, you know, perhaps like SARS-1, this virus would just go away. It appears that the virus isn't going to go away. It's likely here to stay, but obviously our goal is to have it here to stay in some more controlled form. So just this week, or actually last week, we gave the first third doses of a vaccine down the hall in the clinic where we do research, just to see how well people would tolerate a third dose and see what sort of boost we might get to the immune response. And then you may have read in the paper that the nice part about these mRNA vaccines, since it's a gene sequence basically wrapped in a lipid coat, is you just have to change that gene sequence. So both Moderna and Pfizer already have the variants ready to be tested. Now, that doesn't mean they'll be rolled out and everybody in the population needs them, but you would like your science and your testing to be a little bit ahead of the public health and the recommendations. So we're already looking into booster doses, variant versions of the vaccine.
Thanks, Nick, for your question. Dr. Newtzel, we have a question now from Patrick Clancy. So Patrick, go ahead and unmute your mic. And there we go.
Hey, Tom, how are you? Doctor, how are you doing? Quick question about the long hauling aspects of COVID-19. I understand that the current vaccines do not prevent you from contracting COVID-19, but they do basically mitigate the effects or manifesting the effects of the disease. In that context, has there been much data as to the possible long haul effects of folks who get the vaccine, don't manifest the disease, but down the road are suffering some of these issues of mental confusion and heart problems and things like that?
Yeah, so it's a really good question as we're learning more about the longer term side effects of COVID. You know, we have to be careful saying mild disease because it may be mild now, but if you have these lingering effects, then it's not a trivial disease. So again, it's something we're learning about because you can only learn about longer term side effects as the virus is around for longer and you follow people who have been infected. So what we know is these vaccines protect you from being infected at all, let's say about half the time. And I'm going to give some broad examples because we have many vaccines. They protect you from getting symptoms, you know, about 90% of the time, and they protect you from being in the hospital and dying, you know, nearly 100% of the time. Okay, so even with what you're talking about, any symptoms at all, these vaccines do prevent people from getting any symptoms. So I would extrapolate that to say, you know, if you don't initially have symptoms, you're unlikely to have prolonged symptoms. I think the second part of that, which you ask, is really important, that if you get a vaccine, we do know that even the symptoms you get, so let's say you still get disease, your symptoms aren't as bad if you've had a vaccine versus you didn't. So then the next question would be, you know, do they last as long or can they continue? And we just don't have the answer to that yet because we haven't followed people in these trials long enough. A really important question, though.
Thank you, Doctor. Now, I just curious, I had a question. So I was just curious on how COVID-19 kind of compares to other viruses that we've had in the past. I know you talked a little bit about H1N1 and SARS, Ebola. Is there something that makes COVID unique or more dangerous than those viruses in the past?
Yeah, that's a really good question. So to have a pandemic, you have to meet 3 criteria. You have to have a virus that can be transmitted from person to person, which this clearly can. You have to have a virus for which most people don't have immunity, which was true when this virus hit. And then it doesn't have to be a virus. It could be a bacteria. I'm just using this as an example. And it has to cause severe disease. So if we have a virus that gives us the sniffles and it spreads quickly around the world, that doesn't qualify as a pandemic. You know, that qualifies as the common cold, and we're just not that worried about it. So really, what coronavirus has that some of those other viruses didn't have, Ebola is more likely to kill you. If you get Ebola, it will be more likely to kill you than coronavirus. But coronavirus is both very transmissible. It spreads really easy from person to person, and it makes more people sick than flu. You know, not as many people sick as Ebola, but more than flu. So it spreads easily and causes enough severe disease that, you know, it filled our hospitals up and has killed 500,000 people. So I really think it's the transmissibility is what's been really different about this virus than some other very serious viruses that we've been able to manage.
Thank you, Dr. Newtzel. We know you have a busy schedule, so we have 2 more questions for you. This first one's from Philip Berger. So Philip, go ahead and unmute your mic.
Great. Yeah, thank you, Doctor. And just to follow on the other, I've done a ton of work here. The other thing I've heard, what makes this one really sneaky is that you can be transmissible without having symptoms. There's a little delayed onset of symptoms where I think in the other SARS, you know, you got symptoms right away. So my question, and I think I agree with you, it's going to be around a while. So we're probably going to have to get annual shots. And I know some of the vaccines, such as the J&J, since they're actually using a virus, the adenovirus, to deliver it, there's a possibility that you may start becoming immune to that. And so like, you're not going to be able to get like a second shot. So I didn't know if you had opinions there. And then if that also holds true for the RNA vaccines, can you kind of get one RNA vaccine, but then the next one's going to be less effective? So just curious there, because I think that's a really interesting dilemma.
Yeah, I mean, that's a very specific point, but it's a good one. Even with influenza, you know, once you've had a lot of influenza shots, a second or third or fourth shot is better than nothing, but you don't really get that same dramatic effect that you get the very first times that you receive a shot. So the mRNA vaccines are unlikely. Again, it's RNA in a lipid coat. They look like they boost very well in animals, and we're just now getting the boost data from the 3rd dose, so I don't have it. I would not expect that to be a problem. You know, I would expect that to continue to have a good immune response. The adenovirus vectors, as you bring up, are interesting because instead of using a lipid coat to deliver that gene sequence, we use another virus to deliver that gene sequence. And if our body makes the immune response against that other virus, as you pointed out, then the immune response could be diminished. So Johnson & Johnson has a huge trial right now. I hope we hear about it. They're the big single dose vaccine with a second dose. And so, you know, we will have results of that soon. And I think we're just going to have to give, you know, 3rd and 4th doses and see how it goes. Maybe we will come up with some schedule where, you know, the adenovirus vector vaccines are great to get as your first vaccine, but we need to boost with a different type of vaccine. And so those are, mix and match sort of schedules, and those are all being studied now as well.
Thank you, Philip, and thank you, Dr. Newtzel. So our last question, so if Rick Reeves, if you want to ask your final question again, Dr. Newtzel, thank you so much for all the insight and all the great information. I think, all of us can learn a lot from this, and just appreciate your time here today. So Rick Reeves, if you want to close, please. Mr. Reeves, can you hear me? Uh-oh.
I see him over there.
I know, I see him too. Rick Reeves. I guess he can't hear me. So I know the question he wanted to ask, Doctor, was maybe if you could leave us with any words of optimism in regards to COVID and to this pandemic. We hear a lot of stuff on the news, and most of it's negative. So if you could maybe just leave us with some words of optimism, that would be great.
Yeah, well, again, we have to continue to be vigilant, but we are definitely seeing numbers going down. We need to vaccinate as quickly as possible. I would ask everybody on this call that as soon as you're able to get a vaccine, please step forward and take your vaccine. We're not only protected by us getting vaccine, but we're protected by everybody around us getting vaccine. So I think a third vaccine on the market is very optimistic news. This partnership with Merck, optimistic news. We need to vaccinate ourselves out of this situation. And again, we're currently in a situation to do that with 3 vaccines and more coming along.
Awesome.
Dr. Neuzil, thanks again for joining us. As Ben mentioned, it was a real pleasure having you on, and just sharing your insight during this unprecedented time in history. We really appreciate it. Ben, if we could throw it to Ben to kind of give out our advancement office.
So actually, so we would like Rick Reeves to stick around if you can for a little bit. But again, put my advancement hat on here. As we conclude, just like to ask everyone for the support for the Fund for DeMatha, which went out in the mail in October. It's critical for our young gentlemen and scholars to support our ongoing mission. So please, if you can give at www.dematha.org or by mail would be terrific. So thank you again so much, Dr. Newtzel. Thank you for your time, and good luck with everything in the future.
Okay, thank you. Bye, everybody.
Thank you,
Hope
Doctor.
to win a basketball game next year.
There you go. That'd be great.
I hope we can have a season, yes. Thank you, Doctor.
Bye-bye.
So everyone, if you want to stick around, we're going to try, see if Rick Reeves, let's see. Rick, can you hear me, Rick? Yeah, I guess Rick can't hear me. TP, do you want to go maybe?
Yep, I'll go over there and get him. All right, hang tight.
Okay.
Give me a minute, all right?
Gotcha. So we're going to actually have a few Q&As for Rick Reeves here. So if you guys want to ask Rick, who's our science chair department, any questions, feel free to do so. We're going to wait. Obviously some technical difficulties here with Rick's mic. So Tom's going to go over and bring him his iPad. So sit tight for a couple seconds, but yeah, we'll let's see here.
This will be the intermission of today's.
Yeah, intermission. First half is over. Wait for Rick here for the second half.
Hey, Blaze Chromiak, graduate of 74. Thanks for having this. It's really great.
Thank you for joining us, Blaze.
Morning.
Yes.
I think you've been on quite a few, haven't you?
Well, I saw the first potential Ebola patient in Mobile that turned out to be a false alarm, but it took the fire company, the rescue squad. These guys came in the moon suits and to the health department where I worked, and they the lady actually walked out. She wasn't seriously ill, but in her history, there was a potential of a exposure from Africa, one of the countries affected, and she had visitors from there the prior 6 weeks, and came in for pretty much an obscure complaint, possibly viral, but nowhere near a serious case. But as a precaution, my the director of the health department, he used it as a kind of an upgrade, a test case. So for the rescue squad, for the all that to evaluate the patient, the emergency room, even our staff too, just to help the lady go from the exam room to the ambulance and get taken to the hospital, because that's the only way they were evaluating Ebola then, sort of like at the beginning of COVID. If you're sick, go to the hospital, go to the ER, don't go to your doctor's office was the advice. So this was all happening, and my nurse and I, we were the ones in the spacesuit, and actually my charge nurse, because she had to gown me and ungown me and ungown and gown and ungown my nurse. So as we were the only ones that once we decided to isolate this patient in a room, that we got it going. So that's what we all did. So just, the Ebola was scary enough, but this thing has really been very scary for everybody. Yes.
Thank you for that, Blaze.
God
So I
bless
think
the people
thank you,
working.
Blaze.
Okay.
So we have Rick Reeves. Can you hear me now?
Yeah, we switched over to my office. We had computer issues. I got three
No.
guys working on it.
So I asked your final question for you that I knew you were going to close with. So she gave us some words of optimism, but sorry, we couldn't get your mic to work. So again, so everyone, Rick Reeves here is the chair of the science department. He's been a faculty member here at DeMatha for 31 years. So if you would like to ask Rick a question, same kind of format here, you can write in the chat bar and we'll call on you and let us know if you have a question or not. So Connor, I think Connor has a question for Rick. You want to get us started?
Yeah, Rick, you've been at DeMatha. This is your 31st year. So what has inspired you to stick around at DeMatha instead of going to another school? What makes DeMatha stand out that you'd want to stay here for over 3 decades at this point?
Well, I think for me, the thing that's made me want to stay for 31 years, when I first came, of course, John Moylan was principal, and John, had the gift of gab. So I intended to be here for 1 year, and then 2 years, and then 2 years turned into 31 years. But for me, the thing that has kept me at DeMatha for all these years has been the students. I mean, I think the students here are just incredible. I enjoy them. Sometimes I get irritated with them, and oftentimes they're irritated with me, but that's okay. I'm here to give them what they need, not what they want. But I have enjoyed every moment with the interactions with the students, and I think that that's what has, for me, made DeMatha so special and so unique amongst the schools that I've taught at. And I've taught at a variety of schools in my career. DeMatha's not been my only one, but the students here at DeMatha really are what make it stand out amongst other schools that I've actually taught at.
Thank you, Rick. Thank you, Connor. So before we go to the audience, Rick, I have one more question for you. So I know you've been here for a while, but just wanted to, curious if you've had, if there's a specific coworker or, student maybe, or someone that you've kind of has inspired you or had a big impact on you throughout your time here at DeMatha. If there was that one person, who would that be?
Well, my students inspire me every day. So there's so many students I can't even begin to mention. But I will say that the colleague that has inspired me the most was someone that many of you may remember in the theology department, Mr. Bill Kelly. He was just an incredible person, not just his knowledge of theology, but just the kind of person he was. He was old school. There's no question about it. He was an African-American gentleman that grew up in Alabama during some of the worst times in this country's history, and he had a different perspective than most of us do. But he and I would have long discussions, and we would talk about lots of things. We both like to read C.S. Lewis. We would talk about books. We would talk about school. We talk about our lives. We talked about the South a lot, since both of us were from the South. But early on in my career, my best teacher, best professor at Carolina was a man by the name of Jim Ebert. And one of the things that he told us, I never intended to be a school teacher. I said, the two things I'll never do in life is sell insurance and teach school. And we see how that's worked out. But when I went back to school the second time to get my degree in science education, he was actually in charge of the science education department. And one of the best pieces of advice he gave me, Mr. Ebert gave me, was that when you're a teacher, you need to find someone that you can confide in, a colleague that you know that you can talk freely and openly and honestly with, that will say to you what needs to be said, and someone that you know will keep your comments in confidence. And for me at DeMatha, that was Bill Kelly. We could say whatever we needed to say to each other. I could vent and he could vent, and we could agree and we could disagree. And when I was having bad days, he was the guy that I went to, and he came to me when he was having bad days. And that just does something for your spirit. And I think more than anything, he was truly sort of a spiritual guide for me. He unfortunately passed away a few years ago. I miss him every day, but I do know that he has never left DeMatha. You know, I've often commented sometimes when we are here in person and we have faculty meetings, we usually hold them in the cafeteria. And as people are talking, when certain things come up, I can almost hear him. He sat at the same place every faculty meeting for over 20 years. And there's just something, I can almost hear his voice, because he was very outspoken. He was very well spoken. And when Bill Kelly spoke, people listened. He didn't have a lot to say, but people listened. And I can still hear him sometimes when issues come up at DeMatha and hear what he would be saying there. So he was probably not just as a colleague at DeMatha, but just overall in my life, he was a person that truly I cherished every moment I had with him, and every day that goes by, I miss him every day.
Thanks for sharing, Mr. Reeves. We got a question here from Nick Davis. Go ahead, Nick.
Hey, Mr. Reeves.
Hey, how are you?
Good to see you.
Good to see you.
I'm doing all right. I've taken pretty much every science class I could get my hands on when I was at DeMatha and like further on in my educational career. So what, like, since I've been there in 2014, what new sciences have kind of been added to like as an option to take, and what specifically are you teaching these days?
Well, we still believe in it's important to get the basics down. I know lots of schools opt to offer all these fancy classes, and they have great sounding names, and they're great in name only. But we do have some additional classes since you've been here. Some of these we may have offered when you were here, but we do have electives like astronomy and geology. And I think since you were here, we've added marine biology. That's one of the newer courses. We offer biotechnology in alternate years. We have all the AP courses. We've actually redone, since you were here, the health program now. So the health class, when you were here, was part of, I think, the PE department. Now health is part of science, and it's much more of a science class. So some of the things you would have done in biology are actually now done in health. So we've actually changed that a bit, and we've actually coordinated the health science with the biological sciences much more. As far as what I'm teaching now, this year I'm still teaching honors biology. I'm teaching 2 sections of AP Environmental Science, which is actually the course that we spend, as I said before, about a quarter of our year talking about infectious diseases and pandemics. And last year in March, we were actually discussing pandemics, and I was talking about Ebola and SARS, et cetera. And I think some of my students actually believe that I had some sort of connection with what's going on now. I had to convince them that I had no power over this. But they said, how could you be talking about this and it happens today? So we do talk about that in the AP Environmental Science class. And then this year, we needed someone to teach a section of chemistry. And I haven't taught chemistry in about 10 years. So I actually have 1 class of chemistry this year. Last year, I also taught the AP biology class, and we offer AP biology alternate years, so I may next year teach the AP biology and not the chemistry. So that's sort of where I am now. But we look to adding new courses as time progresses. But we also think it's very critical that we give our students that foundation, and then when they get to college, then they can begin to specialize and get those classes that they need. And we're always happy to hear that we have students who go into the sciences, because we certainly need science people now. And I tell my students too, from a more pragmatic perspective, there's lots of jobs there. When people talk about jobs, well, there are lots of science jobs just waiting for people to fill.
Thank you, Rick, and thank you, Nick, for your question. I think we have a question from a former staff member here in the development office, Barbara Coyle. How's it going, Barbara? If you want to unmute your mic and ask Rick your question.
Hi, Rick. Hi, everybody. I was thinking about this and didn't really get it together before the Dr. Newtzel left. But if people have COVID now, when or should they be vaccinated? Does anybody have any thoughts on that?
Well, I can say something to that. I actually am in the loop. I do consulting work outside of DeMatha for a number of private organizations, including some medical clinics. So I try to keep updated, and I do get the daily bulletins and alerts from the CDC. Sometimes they're useless, but sometimes they do have bits of information. But I think that one of the things is that some people had actually the idea that if they had COVID, they should not get the vaccination. And the CDC actually says that even if you've had COVID, you should get vaccinated, that you should not avoid that. So if you actually had COVID at some point, or even if you've had the blood test that's shown you've had it in the past and you were asymptomatic, you should still get it. I think the recommendation would be if you had an active case, you wouldn't get vaccinated then. But after the symptoms had subsided, then, and you had recovered fully from that, then I think most medical doctors would probably recommend that then you get the COVID vaccine. We've had a number of students and faculty over the year that's actually happened to, and all of their doctors, to my knowledge, have told them, you need to get the vaccine.
Mr. Reeves, thank you for joining us on today's call. We got one last question here. Throughout all your years at DeMatha, what's been your most favorite subject or favorite class that you've taught?
Well, I enjoy them all, but I started out in biology. So my undergraduate degree is in biology. So I always enjoy teaching biology, but I also enjoy teaching environmental science. And my specific background is in environmental toxicology. And as I said earlier, I did my research in detecting pathogenic, prokaryotic, pathogenic microorganisms. So I don't get a chance to do a lot of that here, but that's sort of my interest. So in the environmental science class, when we talk about toxicology, that's the part that I enjoy most. And I actually try to bring a little bit of that into the biology class too. That's one of the things about biology and the science classes. While they're all different, you can look at them from different perspectives. So I know that I have a colleague here that teaches biology, and she's into plants, more of a botanist. So when she approaches biology and she talks about cells, she talks a lot about plant cells. And it's easy to extrapolate from plants to animals. There are differences, but it's easy to extrapolate from plant cells to animal cells. So for all of us, if we have a special area of interest, it's relatively easy for us to talk about our area of interest, which hopefully gets our students excited. And I tend to find that many of my students are excited about toxicology because it's about poisoning things, and they like to hear about poisons. So I enjoy talking about that most. And I guess that if I had to single it down, the environmental science class would be the one that I really enjoy the most. Though in chemistry, I enjoy talking about quantum. That's always been a fun thing for me, though it's something sometimes students struggle with. But if I had to choose the one class, if I could only teach the one class, I guess it would be the environmental science, the AP environmental science.
Well, thank you, Mr. Reeves. I think that will wrap up our afternoon, obviously with Dr. Newtzel and Mr. Reeves. Just wanted to thank everyone for, again, joining us on our call today. Learned a lot of great information. Rick, thank you again for your time. I know you had class, but thank you for hopping on here. Unfortunately,
it's a little ironic, Mr. Fleury, I have to say it's a little ironic. I'm getting ready to leave my office right now to get my second COVID shot.
Are you really? All right. Well, that's exciting news. Exciting news. Well, good luck with that, Mr. Reeves. Thank you again, everyone, and we'll see you next week at the same time. Thanks, guys.
Bye-bye.